Okay, we are going to calculate the differences in quality of life, or the delta scores, first for each subject before moving on to the next points. And we begin with opening the BPH sample.sav. And right off the bat, I noticed that there were a few extra variables or columns that were not seen in the book. And I noticed that one already says delt QOL, or quality of life. All right, so it already calculated the delta for us right here. So that was half the battle, right? But let's go ahead and learn how we would want to do this ourselves. So if we want, let's just take this variable right here, and I'm actually going to delete it. I was just practicing. So if I go to transform and compute variable, that will create a new variable, and let's name it quality of life delta. And this is the calculation, and this is just like the formula bar in Excel, where I actually double clicked on quality of life base minus, so there's a little minus right there, quality of life at 3 months. So we're looking at the differences for these. And once I hit OK, I think there's a little bit of a lag there. All right, this will pop up. This will just show that it was computed right there. I'm going to reset this because we will be seeing it shortly. And voila, this quality of life delta is the exact same as this. Just notice that the decimal places are there. So let's just go ahead and remove those. And there you go. We have the exact same thing. So within Excel, what do we do when we describe the differences? Well, if I bring up this Excel sheet, then we can say, well, our N across the board was 10. And our baseline average was 3.8. And remember that 4 equals mostly dissatisfied. So just to give you an idea, whereas at 3 months it was 2.1. So we went from mostly dissatisfied to mostly satisfied. All right, that's a great jump to know when we're looking at a Likert scale. And then our difference here, our mean is going to be 1.7, and our standard deviation, I should just put an SD right there, is going to be 1.494. Now, how did I get these numbers right here? Well, that is something that we could have just done at the first place. So we go to transform or analyze, and I feel like you could do it a couple ways. You could do descriptives, or you could also do it in Excel, but I like to do explore. And I'm just going to I could put all 3. In fact, let's just see what happens when we put all 3. We'll start off with the baseline, we'll start off with 3 months, and then we'll look at the changes. Let's look at our stats. We have our descriptives. Perfect. All right, do we want to add any plots? We want to add stem and leaf. Yes, please, because that is part B, isn't it? Yes, it is. And then let's hit continue. And then once we hit OK, we are looking at all 3. So this is where we calculated the base mean. This is where we calculated the 3 months mean. And then this is where we calculated the delta, as well as our standard deviation, 1.494 right there. Okay, so that's part A. And then part B is asking for, what do we got here? Where's my lovely Excel spreadsheet? There he is. Explore the differences with a stem plot. Let's discuss the exploration. So if we go back to our lovely exploration into each data set, and we scroll down to the delta. So this is what we are looking at for our stem plot. Now let's see if I'm just curious. I did not practice this part. I'm going to copy this stem plot, and I'm going to paste it into this stem plot. And I don't know if it'll work. Holy blowy, it does. All right, there it is. But it kind of messed up my jive here. So what I'm going to do, I'm going to zoom out a little bit. I'm just going to put it right here for now. Okay, so there is my stem and leaf plot. What I can do is move this a little bit further down. That way I could cut and paste this. So that way I have everything in order. And I'll bold these. There we go. This is half the fun, right? All right, so there's our stem and leaf. So what exactly should we actually interpret here? Well, I will tell you. First, we should start off with the shape. And I already have these written out for me, and I'll just copy and paste, but I'll explain each. So first off, let's start off with shape. So our shape is that since there are only 10 observations, there's nothing that we can make strong indications. And however, there are no strong indications of departure from normality, meaning that there's really nothing to really show like away from being a normal curve. Okay, so then the next thing we would describe is our location. And our location is a median improvement was done by 2 points. And so we're looking at the median for the location. And then for the spread, we have the differences varying from 4 to -1. So only one really got worse, whereas everyone else was kind of generally right there. So there are my answers. So I'll say the shape one again, just in case you didn't get it. It is, since there are only 10 observations, it is difficult to discern too much about the shape of the distribution. However, there are no strong indications of departure from normality. It's a really long, drawn-out way of saying we really can't say much with this low n, but it is more of a normal curve. Our location is saying that the median improved by 2. Remember, the median is a little bit more robust, so if it was able to improve by 2, that shows really good change. And then our spread is that the differences varied by from 4 to -1. Okay, so let's go to the last part, and that is calculate the mean and standard deviation of the difference. Then test the mean difference for statistical significance. Use a two-sided alternative hypothesis. So let's go back to our data set. And we will go to Analyze, Descriptives, Compare Means, because we're going to compare the means of the baseline and the delta. And that is used with a paired t-test. And so I already have it here. So variable 1 is the quality of baseline, or the quality of life at baseline, and the variable 2 is quality of life at 3 months. Hit options just to look over. I'm at a 95. Great. Let's hit OK and see what we get. So here we go. Here is our mean and standard deviations. Here's our n for correlation. And what we have here is a paired sample t-test. Okay, so there we have our mean. So we could have just figured out our mean and standard deviation straight from this paired t-test, but we got to go the long way to really get the answer. And we have our standard error mean. We have our stat right here, and we have our significance of two-tailed, and that is at 0.006. So this is a hypothesis test, and I'm actually going to copy and paste the answers because it's actually going to be easier for me to just demonstrate like that. So there we go. That way I have that ready to go. Okay, so what are we looking at here? This clearly is significance. This p-value is smaller than 0.05, okay? It's actually much smaller than that. So we are definitely looking at a statistically significant level. In fact, we don't even have to go to 0.05 with this. We can go to 0.01 for our p-value. How nice. So this is truly significant, statistically significant. So what this is saying is, the conclusion of this is, and I'll scroll this down. After treatment, the 10 study subjects showed an average improvement in quality of life scores of 1.7 units, from an average score of 3.8 to an average score of 2.1, with a p-value of 0.058. Wait a second, how come this says 0.0058 when our number was 0.06? That is because this will round to clearly the third decimal place. Now let's just confirm like this in Excel. So what I'm going to do is I'm actually going to take these quality of life base and 3-month number, and I'm actually going to put them in a brand new Excel spreadsheet. Just want to show you what you would do. Okay, so here they are. We have the pre, we have the post. What you have to remember to have is your data and your data analysis button right here. And the way you find that is, well, that's in another video. I'll let you find it. So once it's there, we hit data analysis. Actually, just in case it's not there, because if memory serves me wrong, maybe I did in another class. You go down here to options. You go to add-ins. And then down here it says Excel, manage Excel, you go to analysis tool pack and then Excel add-ins for that. You hit go and make sure that this analysis tool pack is checked. Okay, so there they are. I'm going to hit data analysis. And I'm going to find the t-test paired to sample means. It's the same exact thing. We hit OK. First, we need to put in the variable 1 range, and that is going to be our pre. So when I hit, and I'm going to show you again, this little arrow right here, I'm going to highlight all of these, and then I'm going to hit this button. It'll upload it. And for the second one, I'm going to highlight 3 months later, and there we go. I don't need to deal with this. I can. I don't need to, this 0.05. In fact, since I know it's 0.01, I'm just going to do one of those. And then I actually want it on the same sheet here. So I'm going to hit output range, and this will tell me, I can tell it where I want it to be put. So I want it to put in the top left corner at D1. So I will just put that arrow, press that arrow, select D1, and then go from there. And I hit OK. And look what we got. We have our mean. We even have our t-stat that we can look up in the back of the book. And we can even see our two-sided, and I can draw this out a little bit more. Our two-tailed is at the very bottom. And we have a 0.005773 or 0.0058, or as SPSS says, 0.006. So 3 different numbers that I just showed you. Welcome to this book. But it's really important to see the differences in what and how to go about these calculations. Excel does it, clearly SPSS does it, and having some of the qualitative or the rhetoric, the dialogue to go with it is helpful.